Hello, hello, good morning. Oh, I forgot to turn on the lights. I need to do that really quickly. Otherwise, we get that weird artifact right there. That light. That. All right, that looks a lot better. How's everybody doing today? Happy Thursday? Thursday? Yes, it's Thursday. Thursday. Yeah. Uh, oh, time. It's so hard to figure out what day it is these days sometimes. Okay, so yesterday we very successfully was able to store data into the world and get that data out mutably or immutably. And so I want to start working on resources next, but I was thinking about how I want to store those, and it's probably going to be a very similar thing, a hash map, and then the thing that we're going to store, probably wrap it in like a ref cell so I can get a readable reference to it, but then write to it. And then I was thinking about the keys, like what do I want those to be? I don't think I always want them to be strings because I have to make sure I don't like mistype them throughout the program, but I don't want them to be defined in the ECS program either. So if I could do an enum in our like flocking rust or other simulator that we end up creating, and then in the ECS we just take a generic for the key, it's going to be one type throughout the world, that should work. So I think I understand generics a little bit more after sort of like playing with them before. So I think the idea here is if we come to the entity and you create a generic T, in fact, I can make this a generic K because of key, and we put that there. So if I do that, then let's see. The next thing is we need a K here and a K here. Okay, I don't think there's anything crazy here yet. When we insert, instead of a name string, this is going to be K. And we don't know what it is, so I'm just going to say we take ownership of it. And then that gets inserted in. Okay. So now we have that entry K. Perfect. And query one, name. So this will have to be a reference to a K. Because when you're getting this out, it's always a reference. Go dev, or goe dev? Go dev? Hello. Okay, so I think this will work there. And then for our mod here, we're gonna need to do the exact same thing because we need to give it like the key. Now here I can do a T because we don't know what that is. The world isn't aware of how entity data is using this generic. All it knows is that it needs some kind of generic. So entity data, and we can say that this is with a T. Okay, and then okay, so the name here, you become, so with component, we're adding it in. We take ownership of it there. Query one, this becomes a reference to a T. That's fine. And then, okay, import default for world. This will have to be a T here, and self T new. Oh, you don't care about that. Oh, can I not do that with self? Oh, I can't. Okay. I guess it figures it out by default. All right, now what? Oh, I guess I probably can't do default anymore. I don't think I'll be able to derive default. And that'll be fine because it's generics. So we'll just say the self so self components is a hash map new. Okay, insert. Entry. Okay, we don't need this to owned anymore. It's just the name, and it's owned. So we're good there. Entry. What are you upset about? No method name entry found for struct hash map. Okay, so the K must have equal and hash. So I think we can do that here. Let's see, what was it? If I just do equal. In other language, you program alone, but in Rust, you code it with compiler together. Is that right? I guess that could be right. Yeah. The compiler the compiler team was talking about how they're trying to make the compiler like a tutor, like sort of like a pair programmer. So yeah, I guess in a way, sort of like a robot or disembodied Rust team. Okay, so it needs standard hash. So can I do standard hash? Okay, so now I've defined, like, key must implement these two. Okay, so back to here. Now if we do this, yeah, so now here T must equal that too, where T as equal plus standard hash. Okay, then down here. Okay, so impl T default. So, because you need to know, oh, I could just do the same thing here. Where T, let's see. T is equal plus standard hash. Okay, so now all of our problems are just in the flocking Rust system, which is not terribly surprising because now it's saying like, hey, we're trying to pass in this stir, and that doesn't solve the T. So we need to fix this. The easiest way to fix this would be just go to what I had in mind, which is I want component names .rs here. So then in component names, I want a pub enum component names. And so we know the ones that we know right now, we have a location and we have velocity. So then, okay, so world, we need to know what the type is for this. So the easiest way to do that would be, hey, your component names. That's your type that you're passing in. Let's see. You're back to your work, but listening sort of then back. Awesome. Yeah, I'm glad to do the stream. Okay, so after we give it the type, then down here we're gonna give it this type. So location is just going to become, you don't know that. Component names, location. And instead of velocity, you're going to be component names, velocity. So you should be happy there now. And now there's no like strings, no number, like, well, I guess like these are kind of magic numbers, but not really, because this is where we're building out everything to begin with. So we're fine there. Now we have to figure out like the systems. So in here, our world, okay, so we need a type argument for this. So we do know that world takes in a component names like that. And so our name is going to be component names. This is location. So that's what we get. So locations. Let's see, there we go. Update you, world. You're a type. Component names. We need location. And we also need a velocity. I am Hardliner. Hello. All right. Query 1 needs to take in a reference to these. Oh, you started the ECS library on GitHub? You still need to check it out though. Well, that's what I'm working on now, so it's all good. Let's see. So component names doesn't satisfy equal or hash. So we can fix that. So component names and derive equal and hash. And you can't do equal without partial equal. Okay, then in draw birds, it's going to be a reference here too. Okay. So that will allow me to use strings if I want to use them in like future projects, but also I can just use this component names, and there you go. Now we're able to get everything out, and everything should still work now. Yep, there we go. We have our two entities, and they're flying through the air. Perfect. So next I want to clean up some of these warnings. Let's see, not using that. Not using that. Not using either of these two here. The context is, yeah, we don't use that yet. And then learn. Yeah, workspace directory. Okay, just learn GGEZ. Go ahead and learn that too. Okay, no warnings, no nothing. We can run this, everything will be happy. So I'm gonna close these windows out and say commit. Okay, so with you, we are the keys for the components Hash map are now generic. Okay, perfect. Now using an enum to store the component names. And that'll make it a little bit easier for me to like make sure that I'm not misspelling anything, because that would suck. Like debugging that would be actually surprisingly hard. Okay, so next up, what's next in our world of flocking the flocking simulator? Right, I want to be able to store things like this background color and their bird mesh and be able to get them out, like query them out. So just like the world is, if I can get away with it, the world is the only thing that I'm storing here, if possible. So that means I need some kind of storage for resources. And these are going to be, we only need like one copy of them at a time. And I probably don't need to mutate them very often, but like sometimes I do. Maybe. In this case, background color and bird mesh, they won't need to be updated pretty much ever. So if we come to our world, we're gonna have these resources. Let's take a look. I'm thinking I actually might want to just like restart this. It'll be easier for me to like think through this. Okay, so for my resources, there's gonna be two types. We're gonna have the resource types, and we're gonna have the I guess that would be like the resource, right? So, and then we're gonna have all of the resources together. So I'm thinking I want in resources, we're gonna have the resources that are S. And this will be a pub struct resources. And in here, we're going to store the actual, like all of the resources. Maybe we can even call this like resources data. Yeah, go ahead and do it. I love how Rust Analyzer now can make that change. It's great. Okay, so we have our resources data, which means we need all of the resources, which is going to be a hash map of, let's do the exact same thing. We're going to have the key, and then we're going to have some kind of like data. So probably the resource, but we need to store this, and we don't know how many times we need to copy it, so we should just use an RC. Okay, so we're going to have an RC, and then inside of that, we're going to have a ref cell, so we can mutate inside of it. And inside of that, we're going to have the actual thing. So it's going to be some kind of resource. So like the resource data. I guess we could just call it the resource. And that's what's going to go in here. So resource, like that. And then that way we're going to, well, it's going to be easy. We just like grab this in, and there we go. Like we store it in there. We can mutate it. We can get it out. It'll be happy. Now, I'm surprised this isn't yelling at me. Did I misspell? Oh no, because resources I don't think I'm bringing in yet. So in the world, we need to mod resources. not the world, in the main library. Okay, so pubmod resources. Okay, so you're already here. You're happy with that? I'm kind of surprised this isn't yelling at me about the T, unless it's because it's like not being used. So in here, we're gonna have resources, and you're gonna be a. Well, if you're wondering what's happened, so am I. Resources data. Okay. Unresolved import, no resources data in resources data. Obstruct resources data. Need to get some work done. Well, thank you, I am Hardliner, for stopping by. And have nice work. Okay, so I have this resources data here. What are you upset about? Use crate. So trying to go auto crate, resources, resources data, resources data. Bear, hello Bear. All right, why are you upset at me? Are you really upset at me? Or is it something else? Try restarting a REST analyzer. Like, I'm kind of surprised it hasn't yelled at me about the generic T yet. Which makes me a little bit concerned. Not this T, the T in resources data. That T is pretty general. Yeah, it is. Yeah, okay, so unresolved import, no resources data in, oh, I know what it, okay, hold on. So in resources mod, we have this pubmod resources data. Inside of here, we have resources data that has the pub struct resources data. Why? So the K, I think it should be yelling at me about, but it's not. Did I misspell it? Okay, so there's resources data, like that, and then resource. You did it last night in the Vim script? Oh. Okay, and in our library, we have pubmod resources to get into here, to get into the mod, which gets into this. It was hard to see. Oh yeah, I can imagine. I can imagine so. All right, let's try this again. If I save you, you're gonna yell at me. We're gonna import you. The fact that it knows that this is here. Let's build this and see what like this error gives me. Is it exactly the same? Yeah, it is. Okay, so no resources data in resources. Resources data. Missing field. Resources in here. Okay, that makes sense. Yeah, I don't get it. Okay, so let's, oh wait. Did I not save? I didn't save. I didn't save the file. Ah, that's what the problem was. It was there, and like Rust Analyzer could find it because it was there, but I hadn't saved the file, so that way it couldn't actually find it. Ah, Mr. Halsey, hello. How are you doing, Mr. Halsey? I've been seeing that you've been doing a lot of like text stuff, like 3D text in your game. Is it the same game or is it different now? All right, so let's go. We're gonna get the resources equals. We need the ability to actually get a new resource. Okay, so now you're finally yelling at me about this because I hadn't saved it. It's saying, hey, we don't know what this K is. Let's go ahead and save it here. Also need to bring in hash map. Okay, about time. So we're gonna impl resources data. Surprised it doesn't also make me put it in here. Okay. Okay. Where K is, so we already know that K needs to have equal and standard hash. And then pub function new. Okay, I think it will figure that out. Okay, it's doing well. It's a smaller project that seems to be growing. Oh, that's great. Tommy Luco, hello. Automod. Automod. Allow that. Okay. I don't know why it withheld that message. That was weird. Okay, so Automod was the how. Like, I guess you accidentally put a space between the H and the OW. It did. It autoed on the how. Oh, Automod puts a space in. Okay, I have no idea. Like, Automod, you're drunk. Go home. Okay. I know, Twitch's algorithm is weird sometimes. I wonder if like that's the new way of like trolling people with games. It's like, how did you do that? How? And then Automod picks it up and goes like, well, gotta block that. Okay, so we are able to create a new resource data in here that allows us to do this. So we're gonna do a resources data. New. Now we are going to have to give it a type in here. So it's going to be a different type than this. So we need a K. Like that. And then we're going to have to give you a K here. And K. K. K is also going to implement the exact same things. And then resources. All right. Make you relatively happy. And then we need, I don't even know if we need this self default. I'm just like creating it new from scratch here. So this default is just annoying now. Okay, there we go with that. Do I really need to implement the default? Can I just derive a default? Would you work? No, because you don't even know how to derive a default. So I want to allow. How to do it? Is it okay? Allow default. New without default. There you go. Hey, I told you to allow that. All right, what are you upset about? Field is never read. Oh, that's fine. We'll get there. Don't worry. Also, I thought I just told you. Clippy, new without default. Allow you. Allow. Clippy. Clippy. All right. Well, if I have to, I'll do a default just to make Clippy happy, because Clippy is our overlord. Okay, so we have resources data. We have new with this. Okay, this is all fine. That's going to cause problems here with flocking rust. So where we have our component names, we're also going to need our system. Our system name. Oh no, resource names. We're also going to need resource names. So let's go ahead and add that. Pub enum. And so we know we need to derive equal, partial, equal, and hash. And this is going to be resource names. Okay, so what's the first thing that we're going to do? Well, we know that the two that we're really caring about is the background color. And we also know that we're going to care a lot about the what is it called? The background color and the bird mesh. So bird mesh. Those are our two. So then up here in the library, world, so component names. I think it's the second one now. So you're going to be the resource names. Okay, so you're fine. Interestingly enough, we have to tell you that here. Okay, so we're back to being happy again. You're upset because you're never read. Okay, that's fine. Don't worry about it, Rust. We'll get there. We'll get there. So now I want to like actually add in resources. So if we come to our resource data, we need to insert. Let's see. Function insert mutable cell. It's going to come with a name, which is, we already know, a type K. And then we're also going to come with like the actual resource, which is a type resource. And we're not going to return anything. We're just going to go ahead and insert it in. And if it overwrites or like destroys everything, that's fine. That's not our fault. It's their fault. So self.resources.insert. It's going to be the name and the resource. Okay, there we go. Mismatch type. Oh, right. We need to do the entire RC, new, ref cell, new, and then we can add the resource. Okay, there we go. So we throw that in there. Okay, so we can add these in. Let's go back to our world, and we're gonna do an insert resource or like add resource, and it'll like follow through. Hub function, add resource. We're gonna have the name of the resource, which is a K, and then a what is it here? It's gonna be the resource, which is a type resource. Not gonna return anything. Self.resources.insert name and resource. There we go. All right, so back to our flocking rust in our main library. Let's do our color. Like we could just do them both right here. So we're gonna say world.add resource. The name is gonna be resources names. Resource names, background color, and then the resource is going to be the background color. No, it can't be that. We have to do a resource. And then we have to like add what this is. So okay, so into what we've got, it's gonna be a color. So resources, our resource. So we're gonna have a color, which is gonna have a GGEZ graphics color inside, and that's all we're gonna care about here. So color, and then inside of that, we're going to throw in the background color. Okay, so there you go. Let's also add in the bird mesh. Add resource. Name is going to be resource names, bird mesh. Resource, we have to now add you in. It's a type mesh, which is the that. Okay. There we go, add it in. You're unhappy because it's been like it's gone now. So let's actually clone this for right this second. That'll become unnecessary later. Once we remove it. Okay, so that's great. Now I need to query to get this resource out, otherwise it's completely useless for us. So I need in resources data, I need the ability to query out and like get the resource. So pub function get, like I guess it could just be get. This is going to be a reference to self and the name of the resource. So this will be the name, which is a reference to K. And we're going to return A, and we should have a new type for this. So pub type. This is going to be a resource data. I probably shouldn't call it resource data. I can't call it resource. So like, what do I want to call this? Get resource data? Like, and that's going to be equal to this entire thing. So we're going to return a reference, no, not to that, to get resource data. All right, so self dot resources dot get, we don't have to get mute, just have to get, then a reference to the key, so that's the name, it's already a reference, and we're going to unwrap here. So we should put some documentation in, get a reference to the resource given the key. If we cannot find the resource, we will panic and crash. So that way we'll get that like type hint when hovering over the get, I think. Because this is like passed through to the world. I don't actually, that's a good question. I don't know if it will get that, but when we like, if we go look at it, it's like, why are we crashing? This will help. Okay, so we need to get, so we're gonna come to the world now and hub function get source. Just a reference to self, we need the name, which is a reference to K, and we're gonna return, and this is where that name, that custom type comes in really handy. It's this get resource data. So it's gonna be a reference to get resource data, self dot resources dot get, pass in the name. All right. So you're all happy here. We can head back to the main library. And what I want to do is in our draw where we have this like self background color, I want to extract that here. So we're going to do let our background color equal to self dot world dot get resource, and it's going to be a reference to resource names. Close. Resource names, background color. That gives us this RC and ref cell, so we're going to borrow, which gives us the actual resource, which I think is fine in this case. I think I can now just pass you in as a deref. I wonder if I need to do that to give us, oh, right, I forgot. This gives us the resource. We now need to like extract out. So back to the not the resources data, but the actual resource itself. We now need to like a cast. I'm progressing quickly since the redesign. Oh yeah, absolutely. Yeah, and it was it is interesting how much faster we're able to go once we, well, I feel also like taking a step back to learn the ref cell thing, that's like that's not just like a minor, oh look, I learned that one thing. I feel like that was a gateway to like the next level in Rust development. So it's a maybe a little bit bigger of a deal than what it maybe like feels like initially, because I think that unlocks a lot more types of programming with Rust for me. And so I'm really excited about what we're going to be able to do, and I think it may improve my speed in the future too. I'm not sure. We'll find out. Okay, so we're gonna import impl resource, and we're gonna do the exact same thing we're doing the other one. We're gonna cast to whatever it is, and it's gonna crash if it can't. Is it okay to post a link? It pertains to RC refcell. It depends upon where the link is. So there's some, I've told Nightbot to allow some links, but it really depends. I also have a Discord that links can be posted in freely. It might be easier there, but you could always do the link here, and Discord will either allow it or, sorry, Nightbot will either allow it because I've seen the link before, or disallow it, and I'll decide if I want to. Oh yeah, GGEZ, those are all allowed, so that's fine. Copy link location. Let's go take a look at you. An ergonomic way of saying RC refcell. It's like shared. Oh, is this like a wrapper around RC refcell? It's basically the convenience wrapper around RC refcell. That wrapper helped me wrap your head around RC refcell. Okay, interesting. I might have to take a look at this later to see if I want to use it. Well, I think watching through the John Who video helped me a lot, which, by the way, I posted a link to that in the Discord. So if it's also like on his YouTube, and it's out here. Yeah, this looks pretty cool. I'm gonna wait. I'm gonna start. All right, so impl resource. What I want to do here is cast to type color. If the cast fails, then we are going to panic. So public function cast color. Now, I want to return a reference to this because I don't want to like give ownership out, like we lose everything. So I think this should really be like a color like that. And right now I don't need a mutable version of this. Maybe later I will. But right now, like the other pattern we're doing, like cast color and cast color mute, like cast something mute. So then we're gonna do a if let self color is equal to self. Then we're gonna return color. Otherwise, we're gonna panic and saying not cast to type color as it is another type. All right. So we have that. Okay, so now I should be able to cast color. So back to here. So we borrow, and then I want to cast color. And that now gives us the reference to color. Okay. So then we can use this here. Background color. Now you need ownership of this. I believe I can just can it dereference you? No, I can't dereference you. I can clone you. So like clone the color, which kind of sucks. It's having to like create this color over and over and over again. But to me, this looks like let's see. What are you upset about now? Value dropped while it's like self world. You have the color just because I cloned you, huh? Can I clone you here? Oh, using clone on a copy type. Well, wait a second. Using clone on a copy type, but you're not doing the thing. Consider dereferencing the borrow. Borrow.deref. Doesn't like that there. I don't think I can deref here. It's still this reference. Maybe I can do like 2-color instead of like cast color. Oh, into color. Oh no, but that will consume it if I do into color. I basically want something that like takes a clone of this, because like for some reason you aren't happy like taking a you and like dereferencing unless I like do something like, well, see, when I clone it, it should deref it automatically because that's what like happens with the dot. So happening here, I guess I'm a little bit surprised that you won't let me clone you at this point in time. Temporary value dropped. Where, like, what part gets dropped? Like, is it the borrow? Okay, so it borrows a ref resource, and then we cast from the resource into color and then clone it. Shouldn't that not matter at that point in time? If I wrap this in brackets, yeah, you don't care about this either. What if I do something like let resource equals you, so we get you, and then I want to return resource dot. Do I need to clone? I don't want to clone twice. That feels wrong. Resource dot cast color dot clone here. Ah, okay. Oh, I need to actually return the thing. Using clone. Okay, so then return you. Oh, come on, Rust Analyzer. You can't yell at me for that and then have it not work. Like, you can't yell at me for both reasons. Use a deref. Silence. Hello, Silence E. Where should I use the deref? I don't think I can use the deref here. Oh, I can. Okay, never mind. I'll use the deref there. All right, so that should give me that should give me this. Now, something I was thinking about is we're gonna get resource, which is a just like a reference to this resource. I wonder if I can like put the borrow inside of that. So let's go back to world get resource. Like if I did just like borrow you, then you're going to be upset that we're not returning the right type. Now we're returning a now we're returning this. Oh, expected, a reference, found, owner of that. Okay, so you. So this could potentially work out, in which case I don't even have to put the borrow here. We could put the borrow in here. So get here, we're gonna borrow you. I kind of want to then come up here and create some new types. So pub type, I guess like in this case, it's just a borrowed resource is now you. Oh, you need a lifetime? Let's see, ref. What are you? Can I not do this here? Because I don't know what the lifetime is. And ref is... Refs are borrowed, reference value to value in a ref cell box. Will you figure it out if I use you? So then you're you. Oh, okay, yeah. So, I mean, the entire thing works, but I think like creating a wrapper type around this, like I would probably need to do what we saw in the GGEZ, is create like a struct that wraps around it as the wrapper type, as opposed to this like simple new name of a type that just aliases a different type, because this is maybe not exactly what we need. So that's a little bit sad. I think what we're gonna do is I'm gonna go back, and I'm just not going to do the borrow here, which means in the world, this works here, but like if I try to alias it, yeah, it's still gonna not work. So we're gonna do a get resource data. It's fine. And then we'll just do the borrow when we need to get it. So I think that'll be fine for right now. Okay, so we've got you. The background color should still work. Let's go ahead and run this. All right, so we still have a background color. Let's go ahead and now extract out. So we don't need to store this anymore. So you're not being used there. We need to create the background color. That's fine. But I don't need to store you in here. Okay, that's great. Now let's do the same thing to the bird mesh. Okay, so how is that going to work? Well, we're going to take away our ability to like use it. So I don't care about you anymore. We do use the bird mesh here. We're not going to clone it anymore. We're We're just going to give you ownership right there, and we're not going to use you. So all we store is the world. We're not going to pass in the bird mesh anymore, just the world. So in our drawbird system, we need to extract out the bird mesh here. So that, I think we're just calling this mesh. So that mesh is equal to world dot get resource. Resource name's bird mesh. Dot borrow. Okay, so now we need update. Wrong one. We need resource. Okay, now we need to cast to type mesh. If the cast fails, then we are going to panic. Okay, so cast mesh. Okay, so if let self mesh is equal to self, then return the mesh. Otherwise, panic. All right. Then back to here. Okay, so we borrowed the mesh. They're going to cast to mesh. And there we go. Mismatch types, right? You need to be a reference. Temporary value dropped. Okay, so mesh is this. Oh, do I need to like do it 2 times here? Like store the borrow into a variable. So it'd be like something like borrowed mesh is equal to this. And then let mesh is equal to borrowed mesh dot cast mesh. Something like that. Yeah, that's what we need to do. And as we can see, like it needs to be done in these 2 steps. I can do it, like we could drop the borrowed mesh immediately. I don't know if it's that big of a deal. But this should still work. We should still have birds. And we do. Okay, so we're now able to get out those meshes from the resources. So now we have a resource system that we can add in whatever resources we need and get them out again too, which is really cool. So let's go ahead and clean up all of these warnings. All right, so you really want me to add in a default for resource data, which won't work out too well because of these. Like I won't be able to, I'm gonna have to do that myself. Fine, okay, you win. Impl default, impl default for resource data. I guess you're gonna have a key here, and we're also gonna have a K here, and we also know that K has to implement equal and hash. And we'll do self new. Self resources. Do I have to just do this? What are you upset about? Oh, where? Okay, can I do this now? It's like literally the opposite of the normal pattern, which is normally you just call like default new from here. Yeah, weird, interesting. Okay, so then we're gonna come into you. It's probably a bad idea. Let me go ahead and reset this. I'm gonna do it the other way around. Go you. And return self that, and then in new, we're gonna return self default, like that. Okay, so that makes you happy. All right. You didn't like this, so we'll get rid of you. And we'll go ahead and so impl, we need a T and a K. Default for world T and K, where T. Can I do this? Can I like 2K is can I do something like that? I don't know if I can. Is equal plus hash. Okay, so then we want to do a self. So struct fields, entity data is entity data new, and resources is resources. Is it resources data? It is. Oh yeah, and we need to tell you that you are type T. Your type K. Okay, you didn't like that. I don't think I can do that. I don't think I can do that. Yeah, so we're just gonna do T. Okay. And then up here at the top, we're just gonna say self default, and that's what we return. Okay, so that makes you happy. Unused deref. Use color and mesh. Unused mesh. Oh, why do I have a self there? I don't think I need a self. Graphics. Okay. Oh, no problems. Excellent. That's what I like to see. So now if I run this, everything should still run exactly as we had it before. There we go. So with that in place, I think we can start playing around with the systems and like figuring stuff out. So I think what we need to do, well, okay, how about this right now? We're gonna go back to a single bird, and then I'm gonna have it just bounce around the screen. So when it hits the edge of the screen, we need to update the like reverse the velocities, kind of, sort of. But in that, to do that, our resource needs to have like the screen size. So we need to have like the resolution of the arena size, which is really just gonna be the screen size too. So what is that gonna be? Let's also commit these. So storing the background and bird mesh as resources. And in U, we are able to store colors and meshes as resources. Okay. So next step for this, I want to store a resource for the arena size. So we can get that. It's just gonna be like an XY. It could just be a point. We could just store that as a point. Because all we need is like an XY, and that's it. Maybe that would work for us. The problem is like that's a component right now, so we need like a point, but I don't think that should be too terribly bad. So we should be able to go into like resource here. We can also store a point, which is a point under these like components, because it's the same type of thing. And then we should be able to cast to type points. I don't know if I need these like should be fairly obvious that it's panicking, so I don't actually think I need these comments here. All right, so pub function cast point reference to a point. So this is, I'm now breaking the rule of three. Look at like how similar these panic error messages are. I think what I want to do is have a private function. So function, like create error message, self. We're gonna take in a like a type name, which is a stir, and we're going to turn a string. And then all I'm going to do is I'm going to do a what is it called? A format, where we're going to say not cast to type that as it is another type. Type name, and we return that. And now I can come here, and we're going to panic and pass in self dot create error message. Oh, why do I? Oh, weird. Okay, oops. And so then in here we can put in like whatever the type name is. So in the first one, you're going to be type color. In the second one, you're type mesh. In the third one, you're type point. There you go. Okay, so that makes it a little bit less repetitive. Tommy Luco, you've just been spending 30 minutes replacing the Thuner file manager icon everywhere. Interesting. I hadn't thought about that. I've never really like sort of been into like, I don't know, like one time a long time ago I was like trying to customize the look of everything in the US. And then I was like, nowadays I'm like, I don't really care anymore. Okay, so we're gonna add a resource for the point. Now, I don't know if this is a good idea. I should probably create this as like a different point because it is slightly different. I don't know if it's a good idea to have like this point component do this. This feels wrong to me. Or maybe I should have like a generic type point that's like not in here. Because it's shared across components and resources. Maybe I should have like another like grouping of points, like generic structures. I don't know. I'll think about it and then continue doing it right now. So we're gonna come back to flocking Rust in the main library. So we're taking in context new. Let's go ahead and add another resource in here. So we're gonna say world.add resource. We actually need, before this, we need to let the arena size is equal to graphics drawable size, pass in the context, and we've got this tuple of F32, F32. So this is perfect. So our name is going to be, we have to update you too, don't we? So resource names, you're going to be the screen size or like the arena size. I like that. You're the arena size, and then the resource is going to be that point. So we need a point new, and then it's going to be the arena size dot 0, arena size dot 1. Okay, so that's going to add you in. Oh, right. It's not just that. It's going to be a resource point. That. There we go. That adds you in. Okay. So we've added in the point. I now need to extract that out at the appropriate places, which is going to be a new system. So we need to create a new system for whenever we or when we hit the edge of the screen, we need to do that. So we need to like basically handle in our systems. Let's get a new file here. This is going to be like handle lighting with maybe like handle arena edges. Go to us. All right, so pub function handle arena edges system. We know we're going to take in a world, which is a reference to a world. And we know that the world takes in the two things. So like the first one that it takes in is the component names, and the second one that takes in is the resource names. And I don't think we need to return anything. So in here, what are the stuff that we need? We need the resource size, like we need the resources. We need the arena size, so that borrowed arena size is equal to world dot get resource. It's a reference to resource names arena size dot borrow at arena size is equal to borrowed arena size dot cast to point. Okay, so now we have the arena size. I also need the all of the locations, and I need mutable access to the velocities. So I pretty much need everything here. So let we need the locations. So locations is going to be equal to world dot query one, and it's going to be a reference to source names. This is going to be not resource names, component names, and this can be our location. Then we want to borrow locations. We're just borrowing, and then we're going to cast okay. It's just the vector of components. Okay, that's fine. So we've got all the locations, and let velocities is going to be equal to world.query1 component names velocity dot, in this case we need to borrow a mute. Okay, so we got locations, we got velocities, and we've got our arena size. So at this point in time, we can now loop through all of our locations. So let's do locations dot iter dot enumerate dot for each. Gonna get index and the location. All right, so what do we need to do here? We need to extract out our location. We extract out our location. So location is equal to location dot cast point. We need to extract out our velocity. So that it need to be mutable too. So velocity is equal to velocities index dot cast point mute. Okay. Then we need we have the arena size already, so we're good. So we need to test to see if the location dot, and so let's do like the right hand side first, or maybe we can do top. It doesn't really matter. So if we're at the top, so if location dot y is less than we know is 0.0, okay, then we want to tell the velocity for this. So velocity dot y times equals -1. Okay. Else if location dot y is greater than Oh, and also we wanted to like reset the oh, we do need the locations to be mutable because I need to reset it just ever so slightly. So hold on. We need you to be a borrow mute. Okay. I hadn't really thought about that. Our location.y is going to be set equal to 0.0. Okay. Else if location y is greater than the arena size dot y, then location.y, set that equal to arena size dot y, velocity.y times equals to -1.0. Okay. A completely separate if statement, because if they hit the corner at the same time, we need to be able to handle that. If location.x is less than 0.0, then location.x is set equal to 0.0, and velocity.x times equals -1.0. Else if location.x is greater than the arena size.x, we're going to do location.x is equal to the arena size.x, velocity.x equals -1.0. And I think we need to semicolon there. What are you upset about? Mismatch closing. I'm missing something. Let's see, so that goes to that. This opens. Did I somehow miss or kill? It's like this function, the colors are wrong. So I've somehow screwed this up. So that's open, close, open, close here. This iteration, so like you should be to here. This is what I'm missing. Close there. There you go. Now the colors are all right. All right. Cannot assign to location, which is behind a mutable reference. Oh, I need a cast point mute. Cannot borrow. You need to iter mute. Cannot borrow, so you need to be mute here. Cannot borrow locations. You need to be mutable here. No errors. All right, so let's head back into you. And so we update the locations, and now we're gonna call handle the arena edges and pass in a reference to self.world. And that's it. So if I'm gonna only add a single component now because it doesn't really matter. We've got them both working. So if we run this, we should be bouncing around the edges. I should have had it go the other way because this is a long time to wait to see if it works. Look at this. We have birds bouncing around the edges. So next time, what I think I'm going to do is start playing with the simulation a little bit more. We're not going to have to update the ECS, the BB ECS as much, I don't think, tomorrow. What I want to do is start doing an acceleration along with a velocity. And what that allows me to do is a lot more smoother turning. So what I can do is, oh, you're getting close to the edge. Let's go ahead and like steer you like, oh, I'm still close to the edge. Continue steering, continue steering, continue steering. And then that way it will like be very smooth as it avoids the edges, which will be super nice. This is great. This is perfect. And we can see that it's perfectly handling how big the arena is, which means it's getting that arena size correctly. So, oh man, this is excellent. So I'm gonna go ahead and save all of this stuff. We're gonna see. So what did we add in here? We can, okay, so we can save a point as a resource. I'm gonna go ahead and push that up. And in our flocking rust, we have birds bouncing around the screen. Excellent. And now I can push that one up as well. Okay, so